That was Sophie Carr with Tingle Toes. You're on 94.9. It is 14 minutes past 4 and it's a Tuesday afternoon. That means Creation Ministries International. And today, gracing the airwaves, we'll have Dr. Mark Harwood from Creation Ministries. He's on the line right now. Good afternoon, Dr. Mark.
Good afternoon, Nick. It's great to be on the program again.
Oh, it's great to have you back again. Of course, Dr. Mark, he's got all his tertiary education, comes from the University of Sydney. Bachelor of Science, Bachelor of Engineering, honours, I think, a PhD degree, and very, very smart when it comes to everything in outer space. I hope I got that right. Did I, Dr. Mark?
Yeah, something like that. I used to work in the aerospace industry, Nick. I was involved in the design of all of Australia's national satellites.
Oh, there we go. So, of course, you're the right man to ask when it comes to stuff like, let's say, the moon. I read this thing on Google about the moon, and it says the prevailing theory of the moon's formation is the giant impact hypothesis. The theory suggests that the moon was formed from the debris of a massive collision between the early Earth and a Mars-sized object called Theia, approximately 4.5 billion years ago. And I found that quite interesting because in the first sentence it says the words theory and hypothesis, and it sounds made up to me. And I'm wondering, can you sort of shed a bit of light on this one?
Well, it's really interesting, Nick, because the moon is the closest astronomical object to us, and we've actually walked on it, and sampled its rocks and so on. But there actually is no self-consistent model for how it came about through natural processes. And that's what our culture tries to find, of course, is naturalistic explanations of everything, because we don't want to admit the supernatural into the story. So there have been a number of ideas about how the moon came about over the years, and there were two fairly prevalent models around in the 1960s in particular, and one of the motivations behind the Apollo missions to the moon was to work out which one was likely to be the correct one. And the two of them that were current at the time was one called the capture theory, and the idea there was that the moon was wandering through our solar system and got captured by the Earth's gravitational field. And the other one was called the co-accretion or co-creation theory, the idea that the Earth and the moon formed simultaneously from the same swarm of dust and gas and planetesimals that formed the Earth also formed the moon. So the idea was with the Apollo missions, if they could sample some rocks and bring them back and we could do some analysis, we should be able to work out which of those two was likely to be the right one. Mm-hmm. And the result basically was, when they got back, that they eliminated both of them. So they had a bit of a dilemma. So in the early 1980s, there was a conference held called The Origin of the Moon. And it actually revived an older idea that came from the about 1940s, middle 1940s, and that was the giant impact model. But it didn't have much currency back in the 50s and 60s because people thought it was just too far out. And that's the idea that you've just described. This Mars-sized object called Theia impacts the early molten Earth, and the debris formed the moon, and the Earth managed to recover from that, and here we have our Earth and Moon. But the biggest thing in favour of the giant impact model is that the other models actually failed. Yes. So, if you like, it's the only one left standing. But there are some major problems with it.
Well, I have one major problem, and that is I've seen people firing bullets at things like watermelons, right? And this impact they've talked about would be something like that. I can imagine this sort of object flying through space colliding with something like a watermelon. Yeah. And the pictures I've seen, the watermelon gets blown in every which direction, yet this theory says it all came together and formed these two big circles.
Well, therein is a big leap, because you've got to get all this debris to coalesce into one moon. And do you know that in our solar system, the Earth is the only planet that has just one moon? Mm-hmm. Of all the planets that have moons, they've all got more than one. And so there's a big question straight away: how come there is only one moon and not several? For instance, Jupiter's got 95 confirmed moons, and Saturn has got something like 270.
Wow.
And of those, about half of them were discovered quite recently. They're all very small compared to the planet that they orbit. So our moon is actually very big. It's about 27% the diameter of the Earth,
Yep.
almost, a little bit over a quarter. And it's about 1/80th the mass of the Earth. But all the other planets have moons that are like 1,000th of the mass of the planet. The moons are really tiny. So how come we get one big moon and all the others have got little ones?
Yeah.
It'd be much more likely from that impact model, as you suggested, that all that debris would have coalesced in multiple little moons.
Yes.
Far more likely than one big one. So it's got a lot of unanswered questions. So what they do is they build computer models of how this thing might have happened, and they play with the angle at which Theia collided with the Earth to see how they can arrange it so the moon forms in the right orbit. And that's a bit of a challenge because the moon's orbit is not in the plane of the Earth's equator. It's slightly tilted by about 5 degrees. And you would expect on a lot of these models that, the spinning debris that would come out would end up with the moon in the same plane as the Earth's equator.
Yep.
So it's pretty hard to get the angle right. And also the moon has an almost perfectly circular orbit. So not quite, it's slightly elliptical, but only slightly. So they mess about with this, and then they produce a few other problems, one of which is that most of the moon would have formed from material on Theia. And, they look at the moon rocks that they brought back, and they're very similar to the Earth's rocks. Mm-hmm. And so they think, well, hang on a minute, what's the chance of Theia having the same kind of geochemical properties that the Earth has? Because it just came from, somewhere else, maybe in the solar system or outside the solar system. That sounds like a bit of a long shot that it's going to be such a good match.
Yes.
And so they fiddle around with the angles again, and they think, well, maybe you could arrange it so most of the material of the moon came from the Earth. But if you do that, you can't get the orbits to work properly. And so you end up with this model that is just not self-consistent. In fact, one of the funny things I came across was a very famous astronomer, a guy who was an expert, in fact, in planetary formation, a guy called Professor Erwin Shapiro. And he said jokingly, since there are no good explanations, and by that he means no good natural explanations, he says, the best explanation is that the moon is an illusion. So he's kind of admitting that we haven't got a clue. So maybe it doesn't really exist. Perhaps it's just up there as an illusion.
Okay,
now,
so when man walked on that, they walked on an illusion.
Yeah, that's right. He was obviously joking, but it just underlines the point that, modern astronomers really cannot explain the closest astronomical model to us, object to us, using naturalistic models. And the problem with all of this is that we exclude the possibility that it might have been created by a supernatural God. And, of course, that's what I believe is the case. Yep. The Bible tells us very plainly that on the fourth day of creation, God made the sun, moon, and the stars. And he gave them a role, He said the greater light was to govern the day and the lesser light was to govern the night, meaning the moon, of course. And they were there to give light on the earth and to govern the day and the night and to separate light from darkness. And that makes a whole lot more sense.
Yes, absolutely. You were saying it's made of very similar stuff to Earth. Does that mean that...
the rock...
Is it really white?
No, it's not white. The reason it looks like that and very bright is that when you look at it at a full moon, you're getting very strong reflections from the sunlight straight back onto us. In fact, when the moon is just rising, just coming up above the horizon, it often has a really sort of golden or yellow look to it. That's because it's going at a low angle through the Earth's atmosphere. Mm-hmm. Sort of the same reason that you get sunrise and sunsets are often orangey and pinky shades,
Yep.
So, no, it's actually got very similar chemistry in the rocks, with a couple of interesting exceptions. It's very low in the element iron, and they're quite distinct. The moon rocks can be told, you can distinguish them very easily because of the very low levels of iron in moon rocks compared to Earth rocks.
Wow.
And it's fascinating. It's like God created the moon similar to, but not exactly the same. And that defeats any kind of simple explanation. Oh, it just spun off from the Earth or something like that. It's just too different. But, it's got other problems. This whole idea of the collision, you can imagine how much energy would have been released, and everything would have been incredibly hot. So anything that's volatile, anything that could evaporate, would have done so. And yet you find that there are things on the moon, like water.
Yep.
But water would have evaporated away. So how come we find evidence of water on the moon? Now, there's actually water ice in some parts of the moon in craters that are shadowed and never see the sun, so they're very, very cold. And there's water, the element H2O is the compound H2O. That molecule is found in some of the rocks in the form of hydroxyl. So there's actually quite a deal of water on the moon, but all of that would have just would boiled off if there'd been a collision.
Yeah, absolutely. I've heard them say that they could use the water or the hydrogen in the water to send spacecraft to Mars, and that's something that people like Elon Musk have talked about more recently. Yes.
There's a lot of work being done on that, but I'll tell you what, there's a long, long way to go before that becomes practical.
Yes.
But you never know. That's the thing about that is that's real good experimental science. It's very clever stuff, but it's based on experiments that you can do in a laboratory that you can observe, and you can test to see your results. You can repeat the experiments. But when you talk about the origin of something in the past, you can't do that kind of science. It's different. You're making up a story about what happened in the past to explain what you're observing in the present.
Yep.
But you can't do experiments. You can't repeat the experiments. You can't test your assumptions in the normal scientific way.
Yeah.
And that's why when we talk about origins, where things came from, it's not the same as doing laboratory-type experiments.
Absolutely.
So the kind of science which builds satellites and spacecraft and all that sort of stuff is not the same as, if you'll forgive me for calling it storytelling science, that makes up a story about what happened in the past to explain the present.
Yeah.
And so much of what we hear today is storytelling science trying to explain in natural terms how the universe came to be.
Yes, with theories. You are on 94.9. It's 27 minutes past 4. We're with Dr. Mark Harwood. And if you have any questions for Dr. Mark, love you to send them through to our text line. It's 0401 949 949. We're going into a little break now, but we'll be back with Dr. Mark after the news, weather and a couple of songs. That was Toby McInholland with Lights Shine Bright here on 94.9. It's 23 minutes to 5. And we have Dr. Mark Harwood from creationministries.com, or Creation Ministries, on the line. And he has a website, or they have a website, called creation.com, where you can go pretty much any time, day or night, and search for answers to limitless questions. I mean, there's literally thousands of pages of information on there, and definitely an awesome resource. But right now we have one of their major resources on the phone, Dr. Mark Harwood, who's been talking to us about the moon. And I got to say, it's pretty interesting. Firstly, I just found out the moon isn't white. I mean, that just blew my mind. I mean, seriously, I always thought the moon was white. I bet you did too. Seriously, even when you see the pictures from the moon landing back in the 1960s, it looked like it was kind of whitish. But then again, so did everything. Literally everything on the moon looked white. That's weird and different. But the way the moon was created, yes, I've heard theories, I've seen theories, I've read theories, and they all sound weird because they just don't seem like they could work, except for that one that you mentioned, Dr. Mark, and that was that, well, God made the moon.
That's right. That's what the book of Genesis tells us very plainly. And so it's not surprising that we can't find naturalistic explanations for how the moon got there. There isn't one that is self-consistent that really works. But there's lots of evidence that the moon has been designed. And one that I love is that the moon, although it's 400 times smaller than the sun, it's 400 times closer. So it appears to be the same size in the sky. And that's just incredibly unlikely to happen by chance.
Yes.
That's just too big a fluke. But what it means is that we experience from time to time total solar eclipses.
Yes.
And we're the only planet in our solar system that does experience a total solar eclipse. And it's quite amazing. We don't get a total solar eclipse every time there's a new moon, because the orbit of the moon is slightly tilted with respect to the equatorial plane of the Earth.
Yep.
But it does happen every now and again. And we've learned a great deal from that. In fact, the element helium was discovered because of a total solar eclipse.
Wow.
And the corona, the sun's atmosphere, was observed during a total solar eclipse. You can't see it at other times. And so it's really quite amazing. But the other thing the moon does, because it's quite big compared with other moons in the solar system and relative to their planets, we have a very big moon, it influences the tides. And so you get 2 tides a day, 2 high tides, 2 low tides. It actually cycles about every 25 hours, not 24. So the times of the tides shift progressively as the days go. But those tides are very important because they oxygenate the coastal waters. They stop the waters getting stagnant, and that helps to foster coastal life, marine life and what have you, sea creatures, and the whole ecosystem, in fact, down the coast functions because of tides.
Yeah.
And if we didn't have a large moon that caused those tides, we would have stagnant waters down our coast, and it'd be. But here's the thing: if the moon was too small, the tides wouldn't be big enough to be effective. But if it was much bigger, then you'd have huge tides thundering up against the coast twice a day. To make life impossible.
Yep.
So it just seems to be just right.
Yeah, Goldilocks.
Sometimes it is. That's what I was going to say. Sometimes the Earth gets called the Goldilocks planet because everything seems to be just right.
That's interesting, though. We always talk about Goldilocks in regards to its distance from the sun, but now even the moon and its distance is also Goldilocks. Yep. So it's Goldilocks in more than one way.
Oh, it's Goldilocks in countless many ways. Our Earth's atmosphere has got the right mixture of gases in it, for instance. Not too much oxygen, not too little. We have to have enough to be able to breathe and to function well, of course. But if there was too much oxygen in the atmosphere, then it would be given to spontaneously combusting, and you'd have, raging fires all over the surface of the Earth.
Wow.
So it's just beautifully balanced, just in every respect. The other really interesting thing is that we only ever see one side of the moon facing us.
Yep.
And I used to wonder about that. I used to think, how could you get the moon spinning on its axis at exactly the same rate that it takes to orbit once around the Earth, so that one side always looks? Surely you'd think that there'd be some sort of drift over time.
Yes.
But it turns out it's actually a mechanical locking sort of process. And what happens is that the Earth produces a gravitational gradient across the moon. So the side of the moon closest to the Earth gets slightly stronger gravitational forces than the side of the moon furthest away. And that has the effect of slightly stretching the moon. So it's not a sphere. It's a little bit like a football shape.
Wow.
And if it tries to turn away, then because of that shape, there are gravitational torques that get exerted that turn it back. So it's actually held, if you like, in that orientation.
Wow.
So we just see the one face of the moon. But when you look up at it, and in fact, if your listeners go out tonight and have a look, the moon will be fairly high in the sky. We're heading for a full moon later this week. You'll see there are dark patches on it.
Yes.
And you might have heard the expression people talk about the man in the moon.
Yes.
If you've got a really good imagination, you might be able to see the profile of a face or something.
I've seen the cow on there.
Yeah, I think you can. I think you can see all sorts of things actually. But those things are they're called maria, which is Latin for seas. And originally, people thought that maybe they were huge lakes or oceans on the surface of the moon. But we now know that they're massive basalt plains, which have been produced by huge impacts on the surface of the moon, which have released massive amounts of lava that have flowed out across the surface and then solidified. And that's what these dark patches are. Basaltic rock is generally black.
Wow.
And so they're the dark areas that we see. But what's fascinating is that when you go around to the other side, and of course we can't see the far side here,
Yep.
so you have to send a spacecraft around it with a camera. And when they did, they discovered to their amazement that there are almost no maria on the far side of the moon. They're only on the side that is the Earth. So what that tells us is that these impacts, these massive asteroids or whatever hit them, must have come in a very, very short space of time, like a huge swarm that came whistling past the Earth, smacked into that face of the moon,
Yep.
and probably all happened in the space of about 1 or 2 days at the most. And if it had been much longer than that, as the moon rotated, you would have seen, a fairly distribution, perhaps even a uniform distribution of these maria, these dark patches. But it's not like that.
Yes.
It's only on the side that faces the Earth. And so I think, and a lot of other creation scientists believe, that that swarm of asteroids, some of them would also have hit the Earth, and they may have been part of the mechanism that triggered the flood of Noah 1,600 years or so after the creation of the Earth.
Yep.
And shattered the Earth's surface, caused the fountains of the great deep to burst forth, and you had volcanic eruptions on the Earth, as well as releasing massive amounts of subterranean water, which, along with torrential rain for 40 days,
Yep.
triggered the flood, which covered the whole of the Earth.
Yes.
So when we look up at the moon, there's like a marker there, if you like, a fingerprint in a sense, that points back to the global catastrophic flood that we read about in the book of Genesis.
Wow.
So
That's
it's
awesome.
quite an amazing thing when we look at our moon.
Yes. Wow. I'm going to look at it in a completely different way next time I look up at the moon. I'll be going, wow. But I'll tell you what, now that you've said that, I'd kind of like to see the other side of the moon.
Well, you can jump onto the internet, and NASA's got photographs, and what you see on the other side, there are lots and lots of craters, but they're all small ones, not big enough to release huge amounts of lava and basaltic lava flows over the surface, like the maria on the side facing us.
Yep.
So it looks pockmarked, looks a bit like a teenager's face with acne,
Yep.
So it's definitely covered in little craters, but only little ones. But the side facing us has got those huge lava flows on it, along with lots of little craters as well. So it's definitely not a uniform distribution of craters around the moon. And it looks like a very short, sharp burst for just a day or so of heavy bombardment that would have caused those massive dark patches that we can see.
Yep. All part of the Lord's creation.
It is. And we've got a couple of minutes. There's a few other interesting things that tell us that the moon can't be as old as what we're told. It's supposed to be 4.5 billion years old. That's the age of the Earth-Moon system, according to the evolutionary story.
Yep.
But one of the things the Apollo astronauts did, they left things called corner reflectors on the surface of the moon. So if you fire a high-powered laser at the moon, you can get a reflection straight back again, and that enables scientists to measure the distance between us and the moon very, very accurately.
Yes.
And it turns out...
Dr. Mark, I've been asked as well, if you can answer in this, because we've only got a minute or so, is the moon volcanic? And also, do meteorites only fly through space in one direction?
No, they fly through in all kinds of different directions. The moon does have a molten core, but it's very small. So you don't see things like we do on the Earth with volcanic eruptions happening. The only reason we have those lava flows is because of the massive bombardment that I mentioned before that must have happened over a very short space of time.
Yep. Wow.
So when these guys measure the distance between us and the moon, they discover that it's actually receding from us, not very fast, about 3.8 centimetres every year, which doesn't sound like much at all.
No.
But if you wind that process backwards, it shows that the Earth-Moon system can't be anything like 4.5 billion years old at all.
Oh, yeah.
In fact, absolute maximum is about a third of that, and practically it would be way, way less than that again. So the secularist has got a big problem because it looks like the moon is way too young to fit this evolutionary story, this fear impacting the proto-Earth 4.5 billion years ago, really doesn't get supported by the evidence that we can observe.
Wow, that's awesome. Well, Dr. Mark Harwood, another awesome week. And look, we've come to the end of our time, but will you be with us next week?
I will be. That's right. Looking forward to that.
Awesome. So are we. You are on 94.9. It is 10 minutes to 5. We'll speak to Dr. Mark Harwood again next week. If you'd like to tune on in at same time, same channel. And if you have any questions, please send them through to our text line 0401 949 949. Thank you, Dr. Mark.